What's up guys, Ryan Tech here. Today I'm going to be doing a video about moving free body diagrams and free body diagram pulleys. So let's get started with moving free body diagrams. Now in this problem it says a car speeds up from 25 meters per second to 60 meters per second in a matter of 5 seconds. Part A is asking the acceleration of the car. So let's get started. The first thing we need to do is write down our info. So I'm going to write down inside the box 1,200 kilograms. In the question, as it said, our V final, horizontally of course, is equal to 60 meters per second. And our V initial, horizontally, is equal to 25 meters per second. And our time, or elapsed time rather, is equal to 5 seconds. Now, what is the acceleration of the car, they're asking. Now, to approach a problem like this, you have to realize what we have to do. And after much consideration, you realize based on what we have known in the question, the most logical thing to do at this stage is to list down the kinematic equations and try solving this problem using a kinematic equation. So let's do that. So let's test out the kinematic equations. We have V final is equal to V initial plus acceleration times time. We also have V final squared is equal to V initial squared plus 2AD. We also have delta Y, or we could say distance, is equal to V initial t plus 1/2 AT squared. Once testing all of these out, you'll realize that this one doesn't quite work. This one doesn't quite work at all, honestly. But you'll realize that the first one, V final is equal to V initial plus AT, does work. Okay, with that, let's use the formula. So V final, 60. Now, yeah, let's plug in the numbers. So 60 is equal to 25 plus the acceleration in the x direction, which we don't know, times 5. Now, if we move this to the other side, and the units is meters per second, it's going to be 35 meters per second is equal to the acceleration in the horizontal direction times 5 seconds. Then, what we could state is that we could divide both sides by 5 and we'll get 35 meters per second divided by 5 seconds is equal to the horizontal acceleration. 35 divided by 5 is 7, and meters per second divided by seconds is meters per second, which is the same thing as 7 meters per second squared, which is our horizontal acceleration. So that's the answer for part A. Now, what does part B want? Now, part B wants the net force acting on the car. So I encourage you to pause this video and see if you can figure out the net force acting on the car. Now, if you assumed you tried it, now for this question, the way we're going to approach it is by using Newton's second law of motion, which is F is equal to ma. So let's use that. So the sum of all the forces is equal to the mass of the car, 1,200, times our acceleration, which is 7 meters per second squared. If you calculate this, then you'll figure out that the net force, or F net, is going to equal to 8,400 newtons. So that's it for part B. Now let's see what part C wants. Part C is asking for the same thing. They're asking for the net force, except they're applying a frictional force. Now I encourage you to pause this video and try part C. Now I've assumed you tried it. Now how do we solve it? Or how do we approach it? Now we approach it the same way. We use Newton's second law of motion, F is equal to ma. We say the net force is equal to the weight, 1200 times 7, but this time we're minusing it by our frictional force, or our kinetic friction, which is Fk. Now, as mentioned in the question, Fk is constant, and they gave it a value of 3,500 newtons. Now, if you minus these two, then the answer you'll get will be the final answer, which is 4,900 newtons. So that would be the net force if we add that constant friction. Now on to a pulley problem. Now this is the part where we talk about pulleys. Now this question says, a 15 kilogram box rests on a frictionless surface attached to a 5 kilogram box. What is the acceleration of the system? Asks part A. Okay. Now to approach a problem like this, there are things that we have to consider and do. The first thing we have to consider is that the tension in the x or y axis is consistent throughout. Means that the tension in the x direction is the same as the tension in the y direction, and it's the same as the tension overall. Same applies to acceleration. So the acceleration in the x or y direction are both equal. So ax, ay, and this is equal to a. The second thing we have to consider is that the tension moves as shown. The tension horizontally moves rightwards in this case, and the tension vertically moves upwards. Next, one thing that we have to do in order to not get confused is label our masses. As shown, we should write down the labels. So this should be labeled as M1, the mass of the 15 kilogram box, and the mass of the 5 kilogram box should be M2. In other words, M1 is equal to 15 kilograms, and M2 is equal to 5 kilograms. Lastly, we have to remember that once we start calculating the sum of all the forces in the y direction, we have to consider that the opposing force of tension is the weight force of the 5 kilogram box, which is M2G. And M2G, for now, we're just going to label it as W2. So not only is the sum of all the forces in the y direction the vertical tension, but it's also equal to the vertical tension minus the weight of the second box, or W2 as we labeled. Anyways, now that we have all of that, let's approach the problem. So to calculate the acceleration of the system, we have to use Newton's second law of motion, which is F, or the force, is equal to M mass times A, the acceleration. So let's get started by using that logic in the horizontal direction. So in the horizontal direction, we can state that the sum of all the forces in the horizontal direction is only equal to the tension force. Because keeping in mind that there is no kinetic friction horizontally. So Fk, or kinetic friction, is equal to 0 newtons. Now the tension in the x direction, based on Newton's second law of motion, is equal to m1, or the mass of the first box, times the acceleration in the x direction, or the acceleration in general. Now that we have it for the x direction, let's calculate for the y direction. Now in the y direction, it's the same thing, except we have to use different variables. Or basically the same thing. There are things different about it. Anyway, now the sum of all the forces vertically, or sigma Fy, is not only, as mentioned, equal to the tension in the y direction, or the tension in general, but it's also equal to that minus W2. We've mentioned that right here. Now W2 is the same thing as saying negative, it's the same as the M2G, and we have Ty here, and that is equal to the sum of all the forces in the vertical direction. Now we figured out that the tension in the x direction is equal to m1ax. I mentioned earlier that the tension in the x direction is the same as the tension in the y direction. That's why we could just substitute for the tension in the y direction is m1ax. So we have that minus m2g, and based on Newton's second law, we could replace Fy with ma, or in other words, for this scenario, m2ay is equal to that. Okay, so far so good. Then we subtract both sides. Now, in order to simplify things and factor out acceleration, we're gonna have to move m1a to the other side by subtracting both sides by m1a. So this is a note here, minus m1ax. Now that we have that, let's do it. So we have m2ay minus m1ax is equal to negative m2g. Now we could just remove the x's and y's. So it's going to be m2a minus m1a minus m2g. So I'm going to rewrite that. And now I'm going to actually factor out a out of it. So it's going to be a times m2 minus m1 is going to be equal to negative m2g. Okay, so now that we have that, we want to calculate or plug in our variables. So this is going to be the same thing as saying 5 minus 15, which is equal to negative 10. So it's going to be negative 10a is approximately equal to negative 5 times 10, because I rounded g from negative 9.8 to 10, or from 9.8 to 10. Now it's going to be negative 10a is equal to negative 50. That means you're going to be left with the answer of a is equal to 5 meters per second squared. That has been it for this video. Hopefully you enjoyed. This question in particular took me a long time because I had two different answers that I was juggling around, but I finally figured out the correct one and why it was correct. There was multiple attempts of this video, so hopefully you enjoyed it. Please subscribe and like. I put lots of dedication into my videos, and as always, have a nice day. Bye! Hey guys, thanks for watching that video. As a special announcement, I have a new Google Classroom. Check out the code. It is XMYZ50G, and that's the code to join. Feel free to join it, and I'll be posting if you guys join it. Bye.